Okay, on this worksheet, we are going to be calculating probabilities that correspond to a binomial experiment. So the first step here is to uh, recognize that this experiment is indeed a binomial situation. So the criteria for a binomial situation would be there are only two possible outcomes. Now, when you're rolling two dice, you can roll a 2, a 3, a 4, a 5, a 6, a 7, 8, 9, 10, 11, 12. So there are multiple outcomes, but we're grouping them into two categories, winning and losing. So rolling a 7 is a win, and so we have rolling a 7 is a win, and rolling a, we could say not 7 is a loss. So we have a fixed number of independent trials. In this case, we have 10 rolls of the dice. So fixed number is 10. Trials are independent. Any one roll does not affect the outcome of any other roll. And we have a fixed probability of success. So the probability of success, or the probability of rolling a 7, is, well, the number of ways to roll a 7. So you have 3 and 4, 4 and 3, 5 and 2, 2 and 5, 6 and 1, 1 and 6. So there's 6 different ways to roll a 7, and with 2 dice, there's 36 possible outcomes. 6 outcomes for the first die, 6 outcomes for the second. 6 times 6 is 36. So the probability of success is 1 out of 6. 1 out of 6. Okay, so now looking at these three problems, number one, find the probability of winning exactly 4 times out of 10. So we're going to use the binomial probability function built into Excel. So we'll do equals. And again, with Excel, you don't need to memorize the function names. Just start typing the word. Start typing the function that you want to work with. So as soon as I type in the first 4 letters of binomial, a very short list comes up, and the first function is binom.dist, and Excel is telling me this returns the individual term of a binomial distribution probability. And that's exactly what we want. So I'll select the first function, binomial distribution, and now Excel is telling me what to input as my arguments of the function. So number of successes, I want 4, and comma, total number of trials is going to be 10. Probability of success is going to be 1 over 6. And the last argument, cumulative function. So again, the cumulative function, if you say yes, that means you want the probability of 0 up through x, the cumulative probability. So if I said yes or true, that would give me the probability that x equals 0 or 1 or 2 or 3 or 4, and add them up. So in this case, I don't want the cumulative function. I want just the value x equals 4. So I'm going to say false. You could type in the word false, or you could use the number 0. So in Excel, 1 means true, 0 means false. Okay, so I'm saying give me the binomial probability of 4 successes out of 10 trials with a success rate of 1/6, and cumulative function is off, so I'll obtain the probability of exactly 4 successes. Okay, so just above 5%. Okay, now number 2, find the probability of winning at most 3 times out of 10. Okay, so in this case, at most 3 times. That means 3 or less, 3 or below. So I've listed all possible, so this 0 through 10, this is the possible number of wins. You could win 0 times, 1 time, 2 times, up to 10 times. So at most 3 means 3 or below, so I'm looking for this range. I want the probability of 3 or below. So the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3. So in this case, I'm going to use the cumulative function. And I'm going to show you using with the cumulative function and without the cumulative function. So with the cumulative function, I'll say equals binomial distribution. So I want 4 successes out of 10 trials with a success rate of 1/6. And in this case, let's go back here. I want 3 successes. 0, 1, 2, and 3. So 3 successes out of 10 trials with a success rate of 1/6, and I'm going to use the cumulative function. So 1 means true. So this is saying the probability, since I'm using the cumulative function, this is going to give me the probability of either 0 wins or 1 win or 2 wins or 3 wins. It's going to give me the total sum of all of those values. Okay, so we're at just over 93%. Now, what's actually going on when we're using the cumulative function is, in this case, 4 individual probabilities. So the most efficient way to solve this problem is to use the cumulative function. But if you don't, what we're actually doing, or what Excel is actually doing, is calculating the probability of 0 wins out of 10 trials and the probability of 1 win, so equal binomial distribution 1 success out of 10 with a success rate of 1/6, and then 2 successes so that's 2 successes out of 10, success rate of, again, 1/6, and 3 successes. So 3 out of 10, success rate, again, 1/6. So these are the individual values: probability of 1 success or 1 win, probability of 0 wins, probability of 1 win, probability of 2 wins, probability of 3 wins. And when we add these up, we should get exactly the same answer from number 2 above, just over 93%, and we get exactly the same value. So using the cumulative function in one step takes, so up here on the function bar you see x equals 3. Using the cumulative function, that takes the cumulative sum of all probabilities from 0 up to the x value. In this case, x equals 3. Ooh, I want to get rid of that. Okay. So now looking at number 3, find the probability of winning more than half of the 10 rolls. So more than half, well, half would be 5. So more than half, we're looking at this group of outcomes. More than half would be 6 or 7 or 8 or 9 or 10. So Excel only works from the left, so 0 up until an x value. So what we could do is we could calculate the probability of 0 through 5 and take the complement of that. So 1 minus the probability of 0 through 5 will give us the probability of 6 through 10. So over here in number 3, let's do 1 minus the probability of 5 or below. So that's the binomial distribution function. We'll say 5 successes out of 10 trials, success rate of 1 over 6, and we're using the cumulative function. So this is going to give me, since I'm using the cumulative function, this is going to give me the probability of 0 or 1 or 2 or 3 or 4 or 5 wins. And then 1 minus that will give me the complement. So since I'm doing 1 minus 5 or below, that's going to give me 6 or above. So probability of more than half would be 0.002 or about 1/5 of 1%. Okay, that about does it for this one.